Average and variation. Measures of location include the mean, average, median, middle value, and mode, most frequent value. Measures of variation assess data spread, with variance quantifying the dispersion and standard deviation providing the average distance from the mean. Quartiles divide the data into 4 parts, and boxplots visually summarize the distribution and spread of these quartiles. Measures of location, or measures of central tendency, are statistical tools used to describe the central point of a data set and indicate where most data values cluster. The primary measures of location are the mean, median, and mode. These measures provide different insights into the data's central tendency, helping to summarize and understand the distribution of the data. The mean, or average, is a measure of central tendency that is obtained by adding all the values in a dataset and dividing the total by the number of values. It gives a single value that reflects the central point of the data. For the dataset 43, 34, 81, 106, 115, and 106, the mean is calculated as 43 plus 34 plus 81 plus 106 plus 115 plus 106, divide by 6, which equals 80.83. To find the sample mean of water absorption percentages given over 24 hours, you need to divide the total sum of the absorption percentages by the number of specimens. In this case, the sum of the water absorption percentages is 229.0. Given that the sample mean is calculated as 16.36. The mean can be distorted by outliers, making it an unreliable measure of central tendency. For example, with 9 employees earning $50,000 and 1 earning $150,000, the mean salary of $60,000 does not accurately reflect the typical earnings. The mean is a straightforward and widely accepted measure of central tendency, making it easy to calculate and understand across various fields. However, its simplicity comes with a drawback. It is sensitive to outliers, which can significantly skew the results and distort the true representation of the data. The median is a measure of central tendency that represents the middle value in a dataset, determined by sorting the numbers and finding the center. For odd-sized datasets, it is the middle value, while for even-sized datasets, it is the average of the two middle values. Unlike the mean, the median is less affected by extreme values and often provides a more accurate reflection of the dataset's central value. To determine the median of the dataset, sort the numbers in ascending order. With 15 numbers in total, the median is the 8th number in this sorted list, which is 23. To determine the median of the given dataset, first sort the numbers in ascending order. With a total of 14 numbers, the median is the average of the 7th and 8th values in the ordered list. Since the 7th value is 21 and the 8th value is 23, the median is 22. The median is a valuable measure of central tendency, particularly for skewed distributions, as it is resistant to outliers and accurately reflects the middle of the dataset. This makes it a more reliable measure of central tendency compared to the mean in such cases. However, the median has its drawbacks. It is less sensitive to changes in the magnitude of values, potentially overlooking significant variations within the dataset. The mode is the value that appears most frequently in a dataset, making it the most common observation. Unlike the mean and median, it does not require calculations, as it is simply identified by its frequency of occurrence. The mode of a dataset is the most frequently occurring value, and a dataset can have one or more modes. For example, in the dataset 19, 8, 29, 35, 19, 28, 15, the mode is 19. In another dataset 1, 3, 3, 3, 4, 4, 6, 6, 6, 9, both 3 and 6 are modes because they appear most frequently. To determine the mode from the given exam scores of 25 students, we first create a frequency distribution. 85 occurs 8 times, 92 occurs 7 times, 78 occurs 5 times, and 90 occurs 5 times. The mode is the score that appears most frequently, which in this case is 85, as it appears 8 times, more than any other score. Thus, the mode of the exam scores is 85. The mode is a measure of central tendency that applies to both categorical and numerical data. For categorical data, it identifies the most frequent category, and for numerical data, the most frequent value. A dataset with one mode is called unimodal, while datasets with two or more modes are referred to as bimodal or multimodal, depending on the number of frequent values. This makes the mode useful for understanding the frequency distribution in various types of data. The mode is a valuable statistical measure for categorical data as it identifies the most common category, making it ideal for datasets such as colors or product types. It is resistant to outliers, unlike the mean, and thus offers a more robust measure of central tendency in skewed data. Additionally, the mode is easy to identify by finding the value with the highest frequency, making it a quick and simple measure to compute. The mode, while useful in some contexts, has notable disadvantages. It may be absent or ambiguous in continuous data or when multiple values share the highest frequency, providing limited insight into the overall data distribution. It can be inadequate for representing central tendency in distributions without a clear peak, and identifying the mode in continuous data can be challenging due to varied frequency distributions unless the data is categorized. Measures of variability assess how much data points differ from the central value, such as the mean or median, and indicate the spread or consistency of the data. Key measures include the range, the difference between the highest and lowest values, standard deviation, the average distance of data points from the mean, and variance, the average of the squared deviations from the mean. The range is a measure of variability that reflects the spread or dispersion of a dataset by calculating the difference between the maximum and minimum values. It is given by the formula, range equals maximum value minus minimum value. This measure provides a quick and straightforward way to understand the extent to which the values in a dataset are spread out. The range of a dataset is the difference between the highest and lowest values. For instance, the range of 7, 6, 3, 3, 1 is 6, derived from 7 minus 1. For 3, 4, 4, 5, 4, the range is 2, which is the result of 5 minus 3. When all values are the same, as in 4, 4, 4, 4, 4, the range is 0, since there is no difference between the highest and lowest values. Standard deviation measures the variation or dispersion of data values in a dataset by quantifying the extent to which individual data points differ from the mean. It reflects the spread of scores around the average, providing insight into the overall distribution and consistency of the data. The sample and population standard deviations both measure data dispersion but differ in application. The population standard deviation applies to entire datasets, while the sample standard deviation is used for subsets of data. The sample standard deviation includes a correction factor to account for the fact that it's based on a sample rather than the whole population. To find the sample standard deviation of the data set 7, 6, 3, 3, 1, calculate the mean 4, then determine the squared differences from the mean, which total 24. Divide this sum by n1, where n is the number of data points, 5, giving 24 divided by 4 equals 6. Taking the square root of this result yields a sample standard deviation of approximately 2.4495. Variance measures the dispersion of values in a data set around the mean, indicating the extent of variability. It is calculated as the square of the standard deviation. High variance signifies that data points are widely scattered from the mean, while low variance indicates that data points are closely clustered around it. The website www.fueleconomy.gov provides detailed fuel efficiency information for various vehicles, including both APA ratings and user-reported values. For the 2009 Ford Focus with an automatic transmission, a sample of 11 user-reported fuel efficiencies shows variation around the APA-rated 27 mpg overall. Rounding effects can cause the sum of deviations from the sample mean to not be exactly zero. For instance, with a calculated sum of squares of 314.106, the size of a typical deviation from the sample mean of 33.26 is approximately 5.6 mpg. This discrepancy is a result of rounding errors that slightly alter the exact deviation values, affecting the overall sum of deviations. The magnitude of a typical deviation from the sample mean of 33.26 is approximately 5.6 mpg. Boxplots, also known as box and whisker plots, provide a clear graphical representation of data distribution by displaying the concentration and spread of data values. They highlight the range of data and the extent of extreme values relative to the majority of the data. A box plot is constructed using 5 key values: the minimum value, the first quartile, the median, the third quartile, and the maximum value, which together illustrate the data's dispersion and central tendency. Box plots offer several advantages for data analysis. They effectively summarize the central tendency, spread, and skewness of data, providing a concise overview of the distribution. Box plots are particularly useful for comparing distributions across multiple datasets or groups, as they allow for easy visualization of differences. Additionally, they are more robust to extreme outliers than histograms, making them a reliable choice for representing data. Their visual clarity ensures that the information is presented in a straightforward and comprehensible manner. Box plots, while useful for providing a broad overview of data distribution, have several disadvantages. Their simplicity can obscure important distributional nuances, and they fail to show individual data points, resulting in a loss of detail about specific values. For small datasets, box plots can be less informative as they primarily rely on quartiles, and they also assume that the data distribution is symmetric, which may not always be accurate. To create a box plot for the test scores of 10 students, first sort the data in ascending order. This sorted data will be used to determine the minimum, first quartile, median, third quartile, and maximum values for constructing the box plot. To calculate quartiles for a dataset with 10 values, first determine the median, Q2, by averaging the 5th and 6th values, which gives Q2 equals 66.5. Next, find the first quartile, Q1, by calculating the median of the lower half of the data, excluding Q2 if the count is odd, which results in Q1 equals 60. Finally, determine the third quartile, Q3, by finding the median of the upper half of the data, giving Q3 equals 72. To determine the whiskers for a box plot, we first calculate the interquartile range, IQR, as the difference between the third quartile, Q3, and the first quartile, Q1, which is 12. The lower whisker extends to the smallest value within 1.5 times the IQR below Q1, giving a lower bound of 42. Similarly, the upper whisker extends to the largest value within 1.5 times the IQR above Q3, resulting in an upper bound of 90. Thank you for watching.